Hello, beautiful people, and welcome. In today's video, we are talking about all things angles. Now, this is in our trigonometry unit, so let's go ahead and jump in. Some of you have already seen trig in your integrated math 2 class, in your algebra 2 class, just like at the beginning of it. So let's go ahead and recall some information. If you haven't, that's fine. This information may or may not be new to you, but let's talk about it. So when we're talking about trig angles, a lot of times what comes up is the unit circle. So let's go ahead and draw a circle. Now, I don't claim that the circle is perfect. It is most certainly not, but let's pretend that it is. So here is our circle. So what do we know about a circle? So let's say if we start here, this is going to be our starting point, and I go all the way around one rotation in a circle, I know that I have 360 degrees. Now, however, if I start here and I don't move, I also have 0 degrees. So 0 and 300, you have the same location. Now, let's say I don't go all the way around. Let's say I go only halfway around. So if I go half of a revolution, half of a circle, we have 180 degrees. Now, notice I am going counterclockwise. So counterclockwise, that's going to give you positive angle measure. Now, if we were to do the opposite, clockwise, then it would be negative, and we'll show you that in just a second. So, okay, so we go halfway, we're at 180 degrees. Well, what if we don't go halfway? What if we only go a quarter? So if we have one full rotation or revolution, 360 degrees, half of a revolution is 180 degrees. 1/4 of a revolution would then equal 90 degrees. And if we go 90 is a fourth of a revolution, 90 is a fourth of a revolution, so 3/4 of the way to one revolution, or 3/4 of the way, is going to be 270 degrees. Now again, that is going counterclockwise. I am starting here, and I'm going all the way around. Now, if I go the opposite way, so let's actually, I'm going to put little arrows here. This is counterclockwise. What if we have clockwise? Clockwise is going to give you the opposite direction. Your initial starting point, it's going to be called initial ray, but initial starting point is going to be the same. It's going to be this pink right here. That's going to not change. You're always starting at that ray or at that side. But now let's go the clockwise. So if we're going this way, then you're going to have negative measures. So from the distance, from my starting distance to 1/4 of the way clockwise, that's going to be negative 90 degrees. Then I go another 1/4, so that means I have 180 degrees negative. So the negative just tells you which direction that you go. You go negative 180 means you went 180 degrees clockwise. This would be 270, and this would be, again, 360 or negative 360. Again, when you are talking about angle measure, like can angles really be a negative? No. What we are talking about is that negative being the direction. So direction. This negative means clockwise. This negative means clockwise. I didn't go counterclockwise, I went clockwise. The angle measure itself is not negative. We are talking about the direction. Okay, so let's talk about, I kind of mentioned the initial ray already, or the starting point. This is going to be your initial ray starting point. Sometimes you'll hear initial side. Initial side or ray. Then you're going to have a terminal, where your angle terminates or where it ends. So let's say I start at my initial side and I go all the way around and I end here. This right here will then be my terminal ray or my ending ray, where the angle stops. This is where I start, this is where I stop, this is called your terminal ray. And again, you hear ray, you hear side. So you always start at your initial ray, you end at your terminal ray or your terminal side. This arrow right here indicates your angle. And it also indicates how many rotations or revolutions you have. So the more circles you have inside, the more rotations you have. Now, keep in mind, even this has a little arrow. Arrows mean it continues forever and ever and ever. So if I don't have a terminal ray, it continues forever. It can go around and circle, circle, circle as many times as we want. So let's go ahead and jump down here. Recall, counterclockwise is positive. Clockwise is negative. So let's draw some angles. It's asking us for us to draw the angle of 430 degrees. Well, 430 degrees is the same thing as saying I have one full revolution or rotation or circle. One rotation or one circle is 360 degrees. How much more do I need to go after that? Well, if I have 360 and I need to go to 430, that means I need to go an extra 70 degrees. So I go one full rotation plus 70 more. Again, this is 0 or 360 degrees. This is my initial ray. One full revolution will get me to 360. This is 90 degrees, and you're always going to go counterclockwise if you see a positive angle, counterclockwise if you see a negative. The negative is just telling you the direction. This is 180. This is 270. Since I have a positive angle, I'm going to go one full revolution or one full circle. This is one full circle. I started and I stopped at the same ray. So right now, my initial and my terminal ray are the same. That means I have traveled 360 degrees. I need to travel 70 more. If I travel a fourth here, that means I'm going to be at 90 degrees now. Too much. I need 70 degrees. So I'm going to travel just a little bit more. And I'm going to stop and I'm going to create a terminal ray. Now keep in mind you want a little arrow there to show that you have traveled one full rotation, one full revolution, one full circle, plus 70 more degrees for 430 degrees. Now for 160 degrees, we're going the opposite direction. So this is 90 degrees, this is 180. Now again, the negative just tells you the direction. You're not actually having negative angle measures. This is 270. This is again 0 or 360. I don't have to travel far because I'm only going 160 degrees. I'm going the opposite direction. This means this is going clockwise. Clockwise to 160 degrees. This is 90 degrees. This is 180 degrees. So is 160 closer to 180 or is 160 closer to 90? 160 is closer to 180. So it's about here-ish. We're guesstimating, but we're doing an educated guess. Here's my little arrow. Here's my terminal ray, and that is it. Now, be careful. You have to show this angle measure here because you may, as we continue today's lesson, may be asked to find a coterminal angle, or it may be asking you to find a reference angle. So be careful. Make sure you indicate that this right here is 160 degrees clockwise. Now, so far we've been dealing with radians. We want to talk, excuse me, I gave it away. So far we've been dealing with degrees. Now let's talk about radian. So what the heck is a radian? So mathematicians are lazy and we get super creative, that's sarcasm, when we're naming things. So a radian is the measure of an angle formed when the radius, get it, radius, radians, is equivalent to the length of the intersecting arc. In trigonometry, you're going to use radians a lot. You're going to want to use radians more than you want to use degrees. The reason being is radians is a larger form of unit measure. Like it, let's draw a picture. So let's say, here's my unit circle. It doesn't matter. It doesn't have to be on an X and Y. Let's just say, so here's a circle. So 1 radian, so here's my center point. Here's my radius. Here's another radius. Here's my theta, or my angle measure, right? The angle measure of, I thought it was a different color. Turns out it's black still. So 1 radian for your angle measure of theta is equal to, is 1 radian is when this arc right here is also the length of the radius. Let me try it again. I feel like I butchered that. 1 radian is when you have the radius equal to the arc. Both of this are going to have the measure of the radius. That angle that they form, that's going to be 1 radian. And 1 radian is the angle that is formed when you have the radius and the length of the arc the same. I think I said that multiple times, so I'm not sure if that came across clear. I apologize if that did not. All right, so let's talk about radians a little bit more. Let's go back up here. When we're talking about radians, we're talking about also the unit circle or the circle. One full revolution comes from the circumference of a circle. So if we have a circumference of a circle, let me use a different sheet of paper. Here's a circle. Pretend that's perfect. A circumference of a circle is equal to 2 pi r. The 1 radian is equal, that should be an A, is equal to 2 pi. So when we have the circumference of a circle, or 1 full circle, 1 full rotation, we know that that's 360 degrees. Now we can say, instead of saying 360 degrees, we can now say that 1 full rotation is 2 pi. And that is based off of our circumference of a circle. And the reason we like radians is because 360 for 1 revolution is a very large number. 2 pi is very much smaller, and we can have more revolutions without getting extremely large numbers. So let's do the same thing we did before. Here's our y-axis, here's our x-axis. So if we have 1 full revolution being 2 pi, half of revolution, again we're going counterclockwise, half of revolution will then be equal to pi. A fourth of a revolution will then be equal to pi halves, and 3/4 of the way, 3 pi halves. So we know that 360 degrees is 1 revolution. We also know that 1 revolution is 2 pi. So using that, we can then convert from radians to degrees and degrees to radians whenever we need to, have an understanding, like a better understanding. Sometimes when I see radians, I'm like, I'm not too sure exactly what that is. I can't visualize it. So I use my conversions to convert from radians to degrees, so maybe I can visualize it better. Or maybe you're better at radians. So let's talk about our conversions. If we have radians and we want to convert to degrees, your fraction that you're going to use in order to convert, that's going to be 180 over pi radians. Now, I will be completely honest, a lot of times you will not see the word radian, R-A-D, rad. You're not going to see that. If it has a pi in it, it's radians. So you'll see 180 over pi, and that's radians. Now, where did this come from? This came from 1 revolution being 360 degrees, 1 revolution or rotation being 2 pi. So that means 2 pi is the same thing as 360 degrees, which means pi is 180 degrees, which we know that here. So we're using this in order to convert from radians to degrees. Now, why is 180 on top and pi on the bottom? Because whatever unit of measure that you desire in your answer, that's going to go on top. Since we are going from radians to degrees, we are then converting in putting 180 degrees on top. If I want radians as my answer, then I'm going to put pi on top. We'll do some examples here in just a few moments. Now let's talk about coterminal angles. Coterminal angles and the next one, reference angles, sometimes get confused because of just the terminology. Coterminal angles start at the initial ray and end at the terminal ray. The actual angle are different. However, the starting and ending of these coterminal angles are the same. So you can have it like a negative and a positive. You can have one going counterclockwise. You can have one going clockwise, but they start at the end at the same spot. They are coterminal. They share the terminal ray. You can have many different rotations. You can have one having 3 rotations. You can have one having 0 rotations and just having a small angle. That can be a coterminal angle. So let's do an example real quick of a coterminal angle. So a coterminal angle could be, for example, let's do one like this. And let's say this is, I'm just going to make one up. Let's say this is 65 degrees. For example. So a coterminal angle would be if I was to start at the same place and end at the same spot. So my terminal ray is the same, my initial ray is the same. However, there's a lot more twirly loop-de-loops in the middle, right? So that means my angle measure is completely different than my coterminal angle. So how do you find coterminal angles? You're going to use what we know about circles and what we know about one full revolution. If you have an angle that is in degrees, your coterminal angle has to be in degrees. If you have an angle that is in radians, then you would use radians for your rotations. So one rotation or revolution is 360 degrees. So how many circles do I have? I have one circle, so I have traveled 360 degrees. Then I have one more circle, so I have traveled another 360 degrees. And then I traveled 65 degrees more. So that means that I have a coterminal angle that is 785 degrees. So what does that mean? That means 65 degrees and 785 degrees are coterminal. We'll do more examples here in just a bit. Moving on to reference angles. Now, reference angles are different than coterminal angles by like a lot. So for reference angles, there's some rules that we have to follow. The first thing about a reference angle is that it is positive, meaning there's no negatives, there's no clockwise positions. We have it being acute. The way I know acute, just think it's a cute angle, meaning it's small and it's cute. Like a kitten is small and cute, so acute angle, small angle, less than 90 degrees. And it's formed from the x-axis to the terminal side. Okay, there's one. I'm going to do a few more and I'm going to show you what that is. So let's say we have an angle. It doesn't even matter what angle it is, but let's say we have an angle, well, I don't know. Let's say we have an angle of 120 degrees. So here's my initial side, here's my terminal ray, And let's say this angle is 120 degrees. Here's my 90. Here's my 0 or 360 degrees. Here's my 180 degrees. And so your reference angle, let's see if I can zoom in. I used pencils, so it's a little difficult to see, is going to be from your x-axis. So here's your x-axis to the terminal ray. Now you have two options. Option number one is this one here. Here's your terminal ray. And here you already have a 120 degree angle. The downside to this is that it's not acute. Acute means less than 90 degrees. Because we have, starting from the x-axis to our terminal right, 120, that means this is not the reference angle. This is the original angle. We want the reference angle. So you're going to go from the other side, Here is your x-axis. Here is your terminal ray. And you're going to find out what this angle measure is, and that is your reference angle. Well, what do I know? What do we know? We know that the entire line of your x-axis, that's 120 degrees. If I have gone 120 degrees, I should have gone 180 degrees to complete that half circle. So what is the distance here in order to get to 80 degrees? And the distance here is 60. So the reference angle for 120 degrees, and that is 60 degrees. It doesn't matter that you're going clockwise because it is always positive. Doesn't matter. It's always positive, always less than 90, always formed from the x-axis to the terminal ray. Let's do a really quick another example. So let's say we have 360. Oh, I'm going the opposite way, so it's negative, but that's okay. Let's say we have this angle here. And let's say this angle, this is 360, so negative, right? We're going the opposite direction. 360 plus 90 and plus, let's do an example. 360 plus 90 plus, oh, I don't know. Let's do 45. So let's say this angle is 495 degrees. And again, it's going negative because it's the opposite direction. We're going clockwise. So that means that we need to find a reference angle. We need a positive, less than 90 angle formed from the x-axis to the terminal ray. Here's my x-axis. Here is my terminal ray. So we need to know what this angle is. So you have options. We know that one full rotation is 130. Just kidding. That was weird. We know one full rotation is at 360 degrees. So if I've gone 360 degrees, I also need to go 135 degrees more. So one full rotation is 360 degrees. And then from here to here, I have gone 135 more degrees. So what is this angle measure in order to complete and get to the rest? And in that case, that is 45. So reference angle, the original angle is negative 495 degrees. The reference angle to that, you guys can't see that, sorry. So the reference angle is 45 degrees. It's super duper duper important that you know reference angle and coterminal angles, and you know the difference between them. Because when you're going to be evaluating exact trig functions, you're going to be able to use these reference angles or coterminal angles in order to simplify and be able to solve them without using a calculator or a cheat sheet. All right, beautiful people, I'm going to wrap up this video here. In the next video, I guess it'll be a part 2. I'm going to do lots and lots of examples that is going to be very similar to either in-class practice if you are in my class or just more practice in general.